What would happen if your warp drive spaceship flew into a black hole? Sounds like science fiction, right? Well, today, we dive into the latest research exploring just that scenario. Buckle up, because we're going beyond the limits of space and time. Warp drives, those iconic tools for faster-than-light travel, fascinated us for decades. Introduced by John Campbell in the novel Islands of Space and popularized by Star Trek, warp drives have become synonymous with exploring distant galaxies in the blink of an eye. But what is a warp drive really? Imagine a spacecraft encased in a bubble that can manipulate space-time, allowing it to travel faster than the speed of light. Sounds cool, right? Unfortunately, it's still just theoretical. Physics problem waiting to be solved. Recently, two researchers, Remo Garatini and Kirill Zatramelov, posed a daring question. What if a warp drive-equipped spaceship flew into a black hole? Their findings, published in Physics Letters B, push the boundaries of what we think is possible in physics. Black holes, regions in space where gravity is so strong, not even light can escape. The authors of the study specifically focused on Schwarzschild black holes, which are non-rotating and have no electric charge. They represent a clean slate for exploring new physics. By combining the mathematics of black holes with warp drives, Garatini and Zatramelov calculated what might happen when a warp bubble approaches a black hole. Here's where it gets really interesting. As the warp drive ship enters the black hole's outer region, the intense gravity would reduce the negative energy needed to sustain the warp bubble. If the ship's speed is lower than the speed of light, it might even eliminate the black hole's event horizon, letting the ship pass through unharmed. This could mean that instead of being crushed by the immense gravity, the warp bubble could safely navigate through, potentially even using the black hole as a shortcut to another part of the universe. So, what does this mean for us today? Well, while we're not yet ready to build starship-sized warp drives, this research could help scientists create mini warp drives in laboratory setting. The idea here is that in controlled conditions, a small-scale warp drive could be experimented with, understand the underlying physics, perhaps even leading to new breakthroughs in our understanding of space-time. Of course, there are still many hurdles to overcome. One of the biggest is the energy required. It's estimated that a warp drive would need an unfathomable amount of exotic matter, something we don't have and aren't even sure exists in the necessary form. Physicist Miguel Alcubierre, who first proposed a warp drive theory in 1994, pointed out that while the math works on paper, we're far from having the technology or understanding needed to make it a reality. The research also suggests that if a warp bubble is small and slow enough, it could even increase a black hole's entropy. But if the warp bubble is too big, it could erase the black hole's horizon, raising questions about our understanding of black hole thermodynamics. This research is a theoretical stepping stone that could lead to future advancements in warp technology. As we unravel more about quantum mechanics and the fabric of space-time, who knows what new discoveries await us. Imagine a future where we can send signals or images from inside a black hole, or use these objects to fuel our warp drives. The possibilities are mind-boggling. So, while warp drives remain in the realm of science fiction for now, research like this keeps pushing the boundaries of what's possible. Perhaps one day, warp drive technology will be as real as the devices we use today. What do you think about the idea of flying a warp drive into a black hole? Could it be the key to exploring the universe, or just another impossible dream? Let us know in the comments below. And if you enjoyed this dive into theoretical physics and space exploration, make sure to like, share, and subscribe for more cosmic content. Thanks for watching. Until next time, keep looking up at the stars.